minutes. So 2 presentations from me, no pressure or anything like that, 2 to deliver on the trot. So I'm going to talk about running AWS locally. Can I ask, in the room, is anybody a developer? Yeah, quite a few. Okay, anybody manage developers? Yeah, I really feel sorry for you people. I'm a developer, I really feel sorry for you. One of the first things that developers ask, how do I run that locally? And with AWS, that brings a challenge, so that's what I'm going to go through. So just a little bit about me. So I'm a freelancer. I do solution architecture, software engineering with my traditional background, moved on into data engineering as well to work with big data. Along the way, I've picked up AWS certifications. Anybody in the room picked up AWS certification yet? Yeah, cool. Anybody planning to do one? Yeah, you should. They're absolutely worth it, both in terms of your knowledge and your commercial value. Absolutely, you should do them. Get in there, get stuck in. On the right-hand side, my social media handles, if you want to get in touch at any point after this presentation, they're up there. So, running AWS locally, why? As a software engineer, I kind of feel like I shouldn't have to answer that question, but often, people ask you, why do you want to do that? Oh, right, okay, right. Why do I want to do it? Why do I want to run AWS locally? So when we're developing, we like to have that tight feedback loop of development. We like to run our code, see it physically work, change it, try again, go again until it actually works. And we want to do that before we push it up into any kind of Git repository so somebody else can't see our mistakes. We like to see the tight feedback loop. There's so much that you can get wrong. Even if you're working with an AWS SDK, you set the wrong parameter, you push the wrong field, you don't necessarily get what you expected, it's good to have tested it. You can use the remote AWS, it's there, it's cloud, you can boot your code up, give it some credentials, let it speak to the live AWS endpoints. The challenge with that is it's kind of going back in time a little bit to the days when multiple developers used to share a database. And we used to hate that because we'd conflict with each other. Who dropped this table? Who changed that schema? Who's pushing data in? Who's doing this? Who's doing that? We'd clash with each other. It made life difficult. With AWS, we could run 1 account per developer, but if you've got a big development team, that's quite an undertaking to be taking on. We kind of ideally want to be able to run this stuff locally. And when you say to developers, do you want to use MongoDB? Yeah, great, I can download that, I can run it. Do you want to use DynamoDB? Well, the answer is you can download it and run it, so the whole, it's not downloadable, is no longer an excuse. In terms of running the services, there's multiple single service options available to us. So if we want to run an individual AWS service on our laptop, on our desktop, we can do that. So I mentioned DynamoDB. Amazon make available a downloadable version of DynamoDB. It can come down as a jar file, it can come down as a Docker container, you can run it on your local machine. It's not 100% replica of what you get on the live service, but you know what? It's a faithful representation that you can develop with and get those bugs and those experimentations out of the way locally. Comes with some caveats? Of course it does. You can't download the live DynamoDB, but you just work with those. If you're working with Lambda or API Gateway, there's SAM Local. Again, similar concept. Download it, run it locally, gives you a faithful representation. If you're working with an AWS service that's actually like a packaged third-party service, you could download that service. So the prime example is Elasticsearch. So if you use Elasticsearch by AWS, guess what? It's Elasticsearch. If you download Elasticsearch from Elastic, run it locally, you get the same kind of output. You can work with that. And then there are a couple of third parties who have tried to mimic what AWS services do. So Minio is a prime example. They've basically built an application that you can run inside of a data center, and it has an S3 compatible API on top of it. So you could download that, you could run it, looks just like S3, works just like S3. It's not S3, but it will be good enough for development with. So you've got these single service options, and you could download them one after the other, get them running locally, and you've got a couple of services. But that's not the best solution that's out there. There is something much better that we can work with, and that's what I'll take you through over the next few minutes. So, LocalStack. Quick show of hands. Who's seen, worked with, or used LocalStack? Like a couple of hands at the back. Yeah, 3, 4, 5 hands maybe. So the rest of you haven't, which is great. So this will be a new introduction for you to a nice, new, shiny world. So LocalStack comes from a company called Atlassian, who are a big global software company. You've probably used one of their products. They run on AWS. AWS is their preferred supplier. I think they're an advanced partner, actually, for the things that they develop. They had this problem. They've got loads of software developers all working with AWS, all trouble having the issues that I stated earlier. So they invested time and effort into trying to build a solution to enable their developers to run local AWS services. It's not the service. It's usually just like a faithful representation of or a mock of that service, but it's good enough for development. And then as these big software companies do, they made that publicly available. So if you go to localstack.cloud, it's all documented, it's all free for use, it's all there for you to just consume and be able to run AWS services on your local machine. So that's just a quick screen grab of their front page. Go there, scroll down, tons of detail. So booting up LocalStack. There's a few different ways that you can run LocalStack, but by far the easiest is to just use Docker. Has everybody used Docker? Yeah? It's becoming, it's becoming so prevalent in our industry. It's like the default way to run things. There's a Docker container available to it. So all you need to do is run this command that I've got on the screen, docker run -p, map your ports between what the Docker container has and your local instance, in which this case is 4580 to 4567, other way around. And then put on localstack/localstack on the end, press enter, and hey presto, you get LocalStack. So here's a quick screen grab from a terminal where I've done that. So line 1 on that terminal is me running that command. The bottom line is what I'm really looking for. It just says ready. Thank you very much. I've got what I wanted. Yeah, no kind of errors and mush and red in between. Here's my command, ready. Plenty of detail in between telling me what's happening if I want to delve into that. But if I'd just zoom in at kind of the bottom half of that terminal, this is what I get. And these are the services that LocalStack is going to make available to me. So top line, I get DynamoDB, listening on port 4569. Fantastic, I've got a database. I get SES, the simple email service. I get Kinesis, I get Redshift, I get S3, I get CloudWatch, CloudFormation, SSM, SQS, Elasticsearch, SNS, DynamoDB Streams, Firehose, Route 53, Elasticsearch Service, and last but not least, I get Lambda. If that's not a good representation of core AWS products, I don't know what is. I don't think when I'm developing I use many services outside of that set, and I don't use most of that. If I get Dynamo, SES, S3, SNS, and SQS, I'm a very, very happy man. Yeah, I've got most of what I need to develop with. And it's just booted them up. Each service listens on a specific port, so I can speak to it, and it's just there, waiting for me to consume. So interacting, it's all great and well being able to boot something up. It is dead easy to boot that up. How do I interact with it? So LocalStack is both CLI and SDK compatible. So you can use LocalStack with your command line in your terminal, and you can use LocalStack with your code, with the SDK. Two important things to note when you're working with LocalStack. It's all about the endpoint setting. So what you do when you're working with LocalStack is you tell it to use a different endpoint. You tell it to use LocalStack, don't use the live version, okay? Otherwise you might be pushing files and messages out to S3 and SQS, and all kinds of chaos can happen. You set the endpoint, and you have to pass in some credentials whenever you make a call to LocalStack. It doesn't check them, it doesn't have IAM, it doesn't fall back to the live IAM, but if you don't pass anything, it gives you an authentication error. So you can pass anything you like, just a random string, a fixed string, anonymous credentials, whatever. As long as you pass something, LocalStack will respond. So here's another quick terminal grab. So I'm going to use the most common service that we're all familiar with, which is S3, right? Have we all worked with S3? Yeah, have we worked with the S3 CLI? So you can sit in your terminal, upload files, download files, sign files, make buckets, delete files, do all that good stuff from the terminal. So AWS S3MB, which is make bucket. I'm going to ask S3 to create an S3 bucket for me. S3:/test-bucket. So my bucket is going to be called test bucket. --profile, and then I put the name of a profile on the end. So this is pretty common if you work with AWS and you've got multiple accounts. You tell it which credentials to use by having a profile. That's all I've done there. And that is exactly what I would do when working with live S3. The difference then comes in on what I've tagged on the end. So on the end here, I've put --endpoint--URL. Careful typing that out, it's dead easy to get wrong. And then HTTP localhost :4572. From the previous slide, S3 is listening on port 4572. And this command, which is the AWS CLI, will speak to LocalStack rather than speaking to the live endpoint. And it's responded in this terminal screen grab. It said make bucket, and it's done it. So it's created a bucket for me in LocalStack. I'll then do one more command. So I'll copy a file from locally into the S3 bucket on LocalStack, AWS S3 CP test.txt, which is just a text file that was sat on my laptop, into the test bucket, same old profile, same old endpoint, and it responds again. It says, yep, I've uploaded it, test.txt up into the S3 bucket. One more screen grab, and then I'm going to list that S3 bucket inside of LocalStack, AWS S3 LS, S3://test bucket, my bucket, my profile, my endpoint, and back it comes with the answer. And that's a list. So if I did that against the live bucket, that terminal response would look exactly the same. I could carry on into more S3 commands, but that would kind of get boring. But I can tell you from previous experience, I can download that file and view it, and it's exactly what I uploaded. So this S3 is doing storage. I can do pre-signed URLs. That works. I can delete buckets. So most of what's in S3 is there. I could also do the same with SQS. I could create an SQS queue. I could start pushing messages into that queue. I could start receiving messages from that queue. I could create new queues, and it will work. LocalStack is a faithful representation of the S3 service for S3 and SQS and for the others. So that's great for my CLI. That's great for me interacting with LocalStack. But the original aim, what I actually wanted, was to take my application code in whatever programming language I'm working in, and I want to point that at LocalStack so that I can see my application working correctly with these S3 services. So to point my application at AWS, at LocalStack, the SDK contains the similar methods to the CLI that I need to be able to do, to be able to set that and to have it work. So I can explicitly set the endpoint, the region, and the credentials that the SDK is going to pass to then pass on to LocalStack. I need to set these inside my application code. So here is a Java example. Anybody lucky enough to work with Java? Yeah, lucky people. Anybody unlucky enough to work with any other programming language? Yeah. Any Windows people in the room? Yeah. The good old tribal rivalry. So this is the Java SDK. From what I've seen, the SDKs across programming languages, they're pretty similar, right? They work in a similar approach. So this works in Java. I know it works in Java because that's what I program in, because I'm lucky. So I imagine you would find the same methods in the PHP, the Golang, the Python, the .NET, whatever other SDK you work with. Syntax will be slightly different, but I'm confident that they'll be in there. So up at the top, that top little black screenshot is how we create an SQS client in Java. With later versions of the SDK, this again has changed slightly, but the principle is there, the principle is sound. I call a static method on the class to give me a builder and ask it to build me a client. It goes and gets credentials from the local machine or from the instance or wherever, and it gives me a client that's speaking to the live SQS in my AWS account. On the bottom is what I replace this with in order to get it to work with LocalStack. So that first line is exactly the same. I've then explicitly called .with credentials and given it some credentials. In this case, the SDK comes with a fantastic little class called anonymous AWS credentials. Don't care what's in there. They're anonymous. It gives me them. And I call .with endpoint configuration, and I tell it where my endpoint is. So again, it's localhost, port 4576. I want to pretend this is in the EU West 1 region, because it doesn't really matter. It doesn't matter where my laptop is. I can lie to it. It doesn't care. And call build on that, and it will give me the SDK pointing at LocalStack. So if I went back in time in my developer days, I would be that person that commented out that first line and replaced it with the second line, got it working with LocalStack, and then forgot to change it back when I pushed up to Git, and then wondered why production was broken, because LocalStack's not there. but I'm past that. So if you've got dependency injection in your development framework, or somewhere passing parameters in, you could if-else that, or use dependency injection with different profiles, whatever your language provides you with, as a means to swap one for the other. Yeah, but it works. It works with LocalStack. So that's using the CLI, and that's getting my application to speak to it. That's not where the uses of LocalStack end. So LocalStack can be used for much wider. So if I can get my application to work with it, and I can get my SDK to work with it, surely I can use this in my continuous integration pipeline as well, right? So if I'm writing code and I'm running tests and I'm consuming S3 or SQS or something else part of those tests, I could run LocalStack inside of my continuous integration pipeline and actually have it speak to LocalStack to get those tests to pass. Push a message into SQS, check if the message is there. It could all be there as part of my automated testing. I can also spin up lightweight or temporary environments. And so this is an issue that I used to have for a client I used to work with. There used to be a team of developers, around about 10 developers, working on multiple features at any one time. And for every feature, we would take that, we would finish it, we would put it onto a testing server to then demonstrate it to the product owner, as was back then, who would then go and demonstrate it to the business, who would then say, no, that's not what we wanted. What we actually want is something completely different. We don't know what we want, but that's not what we want. Send the developer back to start again, or do something else, shift this, move that button, do all that kind of stuff. But it would be quite a long process. Yeah, this whole cycle would tie up a testing environment for weeks or months. And with a team of 10 developers working on 3, 4, 5 features at once, you've got a massive backlog against those testing servers of being able to deploy your code to show them. So with LocalStack, why don't we just take an EC2 instance, install Docker onto it, that's what apt install or yum install, whatever package you're using, install LocalStack on it, Docker run, and you've now got an entirely self-contained testing environment that won't conflict with a testing environment next to it. And you know what? If we're using CloudFormation, which I agree is not shit, we could automate all of this, pull a lever, we've got a new testing environment. When we've done that testing and the business has said, thanks for all your effort, that's not what we wanted, go back again, we just delete that instance and we're done. And we can run as many of these as we want to, freeing up the bottleneck on the testing environment. Going back to that client again, the other bugbear was sales demos. Developers, I know you've done loads of development, but I'm just about to do a sales pitch. Can I have the application from last month, please? I know you're pushing 10 times a day, but tough. I want to know what works when I go and do this pitch. Well, they can have one of those lightweight environments. It's entirely self-contained, its own application code, its own AWS services running on there. It's cool. Sprint demos, those are throwaway. You know, you go, you demo it, you're done, you move on. Spin one of these up, throw it away. Lightweight environments. Anybody use Docker Compose? Yeah? If you've not got your hand up, you are missing out big time. Docker Compose is something that wraps Docker. It means that you can use YAML, because let's face it, we're in the 21st century, it's death by YAML. If you can't write a YAML file, what are you even bothering doing here? You write a YAML file to describe some services, so multiple Docker containers. It will boot them all up. It connects them to each other via a network so that they can speak to each other. And it makes ports available onto your local instance. So if you've got an application that involves multiple services and bits of AWS, you can basically write a little YAML file that would look something like that, and you run one command, docker-compose up, and it will boot up all of your Docker containers and the local stack in this case, network them to each other and give you a fully contained environment. So you don't have to sit there and start up LocalStack. Now I'll go and start up my UI service. Now I'll go and start up my back-end service. Now I'll go and start up blah, 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 blah. It's all in one. You just manifest it in one file, Docker Compose up, fantastic. So if your developers want to have environments that they can boot up really quickly, or you're onboarding a new developer, day one, new developer on board, how do I get the application up and running? That's normally a point of excruciating pain, isn't it? Take a developer off whatever development they're doing, go and help the new person, get booted up, take a whole day out of it. Yeah, Docker Compose up, you're done, carry on. Yeah, so well worth the investment along with LocalStack. Okay, so end of the first presentation. Got any questions on LocalStack? I think I caught them by surprise. They thought it was like another 20 minutes.
Wait.
Let me just wake up.
Okay.
Cheers. Can you use CloudFormation with LocalStack?
So I saw it in there as a service. If I go back, and I'll be honest here and say I haven't tried this. I'm seeing CloudFormation port 4581. So how well it would work, because given that LocalStack, I mean, how would it work? It might just say yes to your stack and then exit. It may create SQS queues in the other service. I honestly don't know, but it's in there, so I guess it's worth an experiment.
It'd be awesome if it did work, yeah.
Yeah, it would, wouldn't it?
Okay. Anybody else? Okay, 1 second, mate. Excuse me.
It's just a question. How often do they onboard new services for LocalStack?
It seems to be a really active piece of development. So in terms of new services, I don't see it that often. Enhancements to existing services, you see quite a lot. But like everybody else on the planet, they struggle to keep up with AWS. Yeah? Even AWS can't keep up with AWS. If you look at CloudFormation, it's always behind. So you're seeing new versions of LocalStack coming out really regularly. It seems to be a really well-adopted project.
Is that okay? Yeah. Any more? Over there, okay. I'm going to start throwing this across the room. Where were we?
I was just wondering about the persistence, because one use case I can conceive of is we might want to move a system which does depend on Amazon services into a more restricted environment where we might not have internet access.
Okay. Right, so there's 2 levels to deal with there. So if you're using, let's say, DynamoDB, with the local version of DynamoDB, you can tell it to save its output into a file, which I guess you could then integrate with this. With Docker containers, if you stop and then start a container again, I can't remember whether or not it keeps its storage. I think you'll be taking a risk, though, with production data. I think you'll be taking a big risk, actually. You'll be really rolling the dice, because it's not really designed for that. I would be ready to lose everything. So, yeah. For demo purposes, cool. For live, yeah, I certainly wouldn't want to go there. I'd be checking my insurance before I did. Let me put it that way.
Bearing in mind, we've got another session from Chris straight away. Is there another question right now on this?
One just squeezes the other.
Okay.
Cool. Okay.
Great. Moving on.
Is that useful to anybody? Think that they're going to go away from here and try and have a look at LocalStack? Yeah. It's, as a developer, it's made my life an awful lot easier. It really has. Okay, so the next one, I've got around about 15, 20 minutes for the next one. Oh, stop moving on. Can I ask, who in the room has used or worked with in any way Glue or Athena? Yeah, 1, maybe 2. Again, a really small handful of people in a room full of quite a number of developers. So hopefully you're going to get another really good piece of value out of this now. So I told you about me last time. Nothing's changed since the last presentation, except I've got a little bit older, perhaps a little bit more grey. Okay, and actually an agenda this time. So I'll go through quickly what AWS, Glue, and Athena are. I'll give you some relevance to application teams. So the title of the presentation was Glue and Athena for application teams, and I'll tell you why it's relevant for application teams and what I think an application team is. Some use cases. I'll do a very dangerous live demo, because all live demos are very dangerous. Yeah, it's not like I'm going to use dodgy data or anything explosive or anything like that. It's a live demo. Some further considerations then, if we've got any time, we'll go through some questions. So, Glue and Athena. Who's heard of AWS Glue and AWS Athena? Yeah, a decent number of hands. We've maybe seen the announcements coming out from reInvent or the updates that are coming out. So Glue and Athena, they live under the big data tool set. But that's really misleading, okay? So that's its primary use case. The big data people love Glue and Athena. If anybody was here for the second presentation this morning by Ewan, I mean, he was really saying, Glue and Athena are like revolutionised their product offering. It's amazing. And he's right, I would agree with him. But it's not just for big data. So when people see big data announcements coming out, most developers, myself included, would say, well, that's a big data piece of kit from AWS. I don't work in the big data field. I'm not in a big data project, so, I'll skip that one. I'm too busy trying to keep up with all the rest of AWS and application frameworks and methodologies and get my work done and, just too busy. But you're missing out. Glue and Athena are really good services to use if you've got any data whatsoever. And I've not yet met a business that used AWS that didn't have any data. Yeah, everybody's got something. Might be a CSV or a spreadsheet. It's cool. It's data. Really useful. So this is actually two services that are closely related. AWS Glue. So what AWS Glue does, it contains something called a data catalog, which if you speak to big data people, they'll often call it a meta store. It's like a representation, or it's a version of something called Hive. If you've got data in storage, you need metadata about your data. You need to know where that data is, what format is it in, what structure is it in, is it zipped, is it not zipped, so that you can work with it. Because most of the time it's just files, it's just data. So if somebody hands you a CSV, you need to know what the column headings are. Is the first row actually a column heading, or is the first row data? You need to figure out things like that. And that's what's stored inside of the Glue metadata catalog. It also comes with something called the Glue ETL, which we're not going to cover in this talk. This is extract, transform, load. So if you ever speak to a big data person, they love transforming data because it never comes to them in the format that they want it. Yeah, that's to extract bits, transform bits, load of the bits, save it away. ETL tool is cool if you're a big data or a data engineer, but we're not going to cover that. Athena is then a fully managed version of a piece of software that was actually produced by Facebook. So Facebook has got massive data. They built some tooling called Presto. They made that open source. AWS has basically got a fully managed version of it, so that you don't need to have any of the pain of installation, management, configuration. You just consume it. It's just there for you to get your hands on. And it's basically a SQL tool. So if you've got loads of data in files and you want to do a SQL query on it, that's what Athena does. So these two services together have got a really kind of low learning curve, really shallow learning curve for basic usage. They've got some complex parts, but we don't need to delve into that. Just as application teams, we can just get in there and we can just consume this. So what do I mean by an application team? I'm talking here about developers, DevOps, SysOps, sysadmin, whatever they used to be called. Those people who, when you say, what do you work with? They kind of say, I work with an application. I build an application. I look after an application. I look after hosting application. They never say, I look after data or I work with data. They're all about the app, okay? So there's some really good use cases for those application type people with Glue and Athena. So I'll go through why now. For the relevance for application teams. And I've seen this so much in my career. So this is called life before Glue. We had option 1 or option 2, which happens to rhyme, which is pretty cool. So we had hot data inside of our data store, which is our database, a MySQL database, a Postgres database, or whatever. It's hot data. It's queryable anytime. We just typically got an application sat over to it, listening on it, but it's got a comparatively high cost. If you want to keep data in a database, that is comparatively more expensive than just putting it into storage, right? Putting it onto your NAS, putting it into S3 or whatever. It's going to cost you more to keep it in that database. You're going to need the compute, you're going to need the CPU, you're going to need the memory, you're going to need to maintain it. It's just got a higher cost. Or we've got the cold data option, which is basically just take that data, bang it out into storage, do a MySQL dump, do an export into a CSV, take those files and just save them, right? Stick them into cold data. The problem there is that when somebody comes to you and says that data that's cold, it's in storage, they say, can you just tell me, all those orders that we exported out of the database and we put into S3, can you tell me when that order changed state to fulfilled? Well, what am I going to do now? I'm going to go to that data in S3 or on my NAS or whatever, and I'm going to have to restore it. So I'm going to have to get some compute available to me, restore it into the database or open the file up and then work with it, which is painful. That data sat in cold storage is pretty inaccessible. You've got to put some effort in to go and work with it. But it's got low cost. It's cheap. So I used to see the battle all the time in the businesses that I used to work with of, do we keep this data in the database or do we move it out to storage? And the answer used to be, well, if there's any possibility that anybody might want to query that data, leave it in the database and incur the cost, because just moving it out into storage and then restoring it was just too painful. Yeah, so we'd see this database that incrementally just got bigger, holding up masses of historic data, audit data, transaction data, old orders. It just built up and built up and built up and built up in there, because option 2, stick it into cold data, just came with too many caveats. It's just too painful. Where Glue comes in is it sits literally in the middle of those 2 options, and that's the beauty of it. So we use Glue and Athena. We can have cold data because our data sits in S3. So Glue and Athena work on S3. We've all worked with S3, right? We're all happy with what S3 is. It's just storage. Really, really, really cheap storage. So it'll query the data that is in S3 without you having to restore it into any other kind of application. And what you're paying for is your S3 storage cost plus a little tiny cost of the amount of time and effort that it takes to query that data. So it charges based on the amount of data that it scans. So if you've got data in S3, you run a query against that data. For every terabyte of data that it scans, AWS will charge you $5. Yeah, which is like ridiculously cheap. So I was doing queries against gigabytes of data, and it was costing me a penny, rounded up. Yeah, it was just like so cheap it's untrue. So option 3 is suddenly on the table. We don't have to go for in the database or in storage. We can do in storage, but still queryable. So some good use cases on that. Traditionally, so for application teams, backups, we shove them out to S3. Exports of data, as in take a table and dump it out to a CSV, that goes into S3 all the time. We can use Glue and Athena on top of those. Data that's too big to be cost-effectively held in this database. Audit tables, they seem to go massive. They go through the roof. Get them shipped out into S3, get that table space back by dropping the rows or truncating the table or whatever, and it's out there. Transaction history, old orders or customers. I used to work in a business where if a customer was more than 2 years old and we'd not seen them with a new order, we'd basically archive them off into storage. Then that customer would inevitably come back the following week. Yeah, and we'd have to go and restore all the records and bring them back in. I think my bank says, we've got all your bank account transactions, Mr. Gillespie, for the last year. If you want to go back older than a year, you better ring us. Well, that's because they're archiving that data out into storage, right? So it's no longer available. And then somebody will go and get the tape and probably bring it back in, try and restore it if I make a query about whether or not I got paid 13 months ago. So Glue and Athena would give them a solution, a perfect hybrid solution in there. Fast-moving data. How much time and effort do we put into maintaining compute that holds onto logs for a certain window? Yeah, who's running an Elasticsearch cluster just to shove logs into it and then spill them out and then bring some more in and spill it out some more? Chuck it into S3 and let Glue and Athena query it. Yeah, if your developers want to do an ad hoc query on logs, if those logs are in S3, chances are Glue and Athena is going to be there as a workable solution, but you will only pay when they do make a query. You'll pay $5 per terabyte scanned, which is nothing compared to maintaining all that kind of Elasticsearch and other infrastructure. So, some great use cases there. We've got 10 minutes for a really quick demo of Glue, so I can just show you just how easy it is, that it doesn't have that high learning curve. Where's my mouse pointer? God, Right, so I've logged into the AWS console, and the first thing that I do is I go into Glue. Okay, so this is the Glue panel. So in terms of Glue, I've got databases, I've got tables, and I've got crawlers, the 3 important things for this demo. And I've got some data in S3. I've just been spilling it out there. I've not been doing anything special with it. The metastore needs to understand that data. So I can need to say to it, there's some data in that part of S3, go and look at it. And then what Glue will do is it will go and it will do a pass over your data. It will try to recognize, is this JSON? Is it a CSV? What are the column headings? How big is it? It'll just basically inspect the data and try and understand it. So if I create a crawler, and I'm just going to call it stock. So I'm just going through this wizard. It's going to ask me whereabouts in S3 is it. I click the little folder, and I know that it's in this little path down here. So what I've just done is just navigate down through S3 to say that prefix, that folder in S3, it's got some data in it. That's where I want you to look. Click on next. Do you want to add another data store, another location? Nope, just go and look at there for me, please. What IAM role, so if this is your first time of running it, just let it create the IAM role. You don't even have to mess about, but I've run this previously, so I'm going to choose the role that I ran previously. I want to run it on demand. I can tell it to run this crawler on a schedule, but you know what? I'll just tell you when I want it to run it. Which database do you want me to put these tables into? So I'm going to ask you to create me a new database called stock. Confirming to me, I click finish, and I'm kind of done. And you can see now I've got a crawler has appeared. So I asked for it run on demand, so I'm going to tick it, and I'm going to click run. So that's now going to go and inspect my data in S3. Didn't do anything complicated there. I just said my data's over there. Go look at it. So this is all serverless, so it'll run in the background. It's not spinning up any infrastructure. I don't have to mess around with EC2 or anything like that. It's going to go and do it. The downside of that being is it can take a couple of minutes to work because I'm probably in a queue somewhere waiting for my timing. So if I have a quick flick around the console just while we're waiting, it's created a database for me here inside of Glue. If I look inside of that database at the tables, it's empty. There are no tables because it's not inspected my data yet. The crawler will be off and running. I can flick over to Athena in the console. So once it's found that data and kind of understood that data, I can issue SQL queries against it, even if it's just a CSV or a JSON file. I've got my database here inside of the Athena console with no tables in it. Yeah, it's not found anything yet. So fingers crossed, I will go back to Glue. And this is where I'm really hoping that it's finished now, otherwise somebody's going to have to start telling jokes to fill the time a little bit. Have you even started? Across to the crawlers. Hey, okay, so it's running. It's giving me a little progress bar there. So it said it's kicked off and run. So I think the last time this took like 2 minutes to run. So we'll just give it a moment. Tell you what I will do. So whilst we're waiting for that to run, I will show you the data that it's going to find. So, I'm on my desktop here, so I downloaded, so there's actually multiple files inside of that path, all done like a date-time structure. And the one that it is going to find looks something like this. Yeah, that's just like a wall of JSON, because it's coming out from Firehose. So it's blobs of JSON, just row upon row upon row upon row upon row of JSON, which looks nasty when you look at it directly. If I pipe it into a lovely tool called JQ, anybody work with JQ? Yeah, so I take that nasty JSON, click enter, and oh my word, that's pretty. Sorry, did I sound like a developer there? I was talking about the JSON, right? Okay, so I'm sure it's not inappropriate to call JSON pretty. I'm sure it's okay with that. But that's what it looks like, yeah? It's just rows upon rows upon rows of JSON data. So I have again lost my mouse pointer. Come back. Let's do a little refresh. Okay, so the Glue crawler is saying it's stopping. It's done. It's inspected my data. Fantastic on that last column. Tables added 1. So it's found one data set. What it's actually found is loads of those JSON files. It's recognized that the data inside those files is so similar across the files that these are not different data sets. It's one data set. So it's going to collate those together inside of the meta store. So when I run a query, it's going to work through all those individual JSON files. Yeah, so so you don't have to kind of take your files and squish them together and concatenate them and mess them around like you would with a table in a database where you're appending multiple files. It'll deal with that seamlessly. So if I go into the databases, I go into my stock database, I go into tables. I've got a table. It's found some table. I can click on the table and I can look and inspect what it's found. It's going to tell me how many rows it's found. It's telling me what the keys are inside of that table. It's telling me what data type these are. So it's recognized strings, integers, dates, all that kind of stuff. it's understood my data in S3. I've not told it anything other than where that data is. Yeah, which is pretty amazing. If I now flick across to Athena, I go into my stock database and I've got a table. I can open up that table and it tells me the schema of this table. So that's come from the Glue meta store. I can now query that table using SQL, select star from stock, limit 10. It's chugging away. So it's charging me $5 per terabyte, broken down, and it's giving me back a set of rows. So what I've got in S3 is JSON data across multiple files. What I've got in Athena is a table that I can query. And I can use ANSI SQL with that. So I can say, select star from this data set where, and then some column, I don't know, age is greater than 10 and postcode starts with, and I can do SQL against JSON data, against CSV data, against a combination of all of the above. So if I'm shipping my logs in there in JSON format, or I'm shipping some data in there, or I've done a CSV export, Glue and Athena is going to work with it, yeah? And I can give then, I've got a SQL tool over the top. So that's a real whistle-stop view at Glue and Athena. Demo didn't go too badly, did it? So, some further considerations. If your data is something like a MySQL dump, which is SQL, yeah, if you look inside of a MySQL dump, you literally get SQL statements, don't you, as opposed to rows of CSV, you might have to do some conversion, because Glue and Athena won't work with SQL, yeah, as in a file that contains SQL. So you need to convert it into CSV or TSV or JSON or whatever. You're charged by the amount of data that's been scanned in a query. If your data set starts to get big, you can manage that by partitioning your data, where you help Glue to understand that based on your query, it doesn't need to inspect certain files in S3. Yeah, but that's a fairly advanced topic. Glue has granular security for IAM, so if you're exporting financial data or personal data and you don't want anybody to be able to access this, you can control that through Glue. And lastly, fantastically, Athena has an ODBC driver. So if you want to use your really nice SQL tool or your business intelligence tool, your draggy-droppy chart type tooling, whatever, you use the ODBC driver, it'll speak to Athena, Athena will look at S3, and you've now got some kind of fantastic analytical tools that's using S3. You don't have to use a database. Okay, literally like 2 minutes left, I think.
Absolutely. Let's get some questions quickly.
Questions.
Has anybody got questions for Chris? Must be.
No? Okay, I've got a question for you. Who thinks that Glue and Athena is going to be of some value to their organisation or to themselves, and they're going to go and have a look at it when they get back? Yeah, brilliant. That's what we wanted to. Yeah. Awesome tool.
Just want to say special thanks to Chris, because he stepped in right at the last minute and saved us. So thank you, Chris. That's
you're
absolutely
welcome.
fantastic. So give him a round of applause, please.
Yeah,
Thank you.
you.